Hello everyone and welcome to our week 5. I hope everyone is doing well and enjoying your week so far. The agenda for today is to talk about the concept of loops in Python. So I will begin by doing a PowerPoint presentation on loops, then go over some code examples. I will also go over the week 5 module quickly, and of course I will go over the week 5 Python assignment in details. Now I will also cover the random library as well as a function called range, because they will be used in our examples and assignment for this week. So let's get started. So loops in Python, as well as in any programming language really, are essential control flow structures that allow the execution of a block of code multiple times, which reduces the need for manual repetition. And Python supports two main types of loops: for loops, which iterate over a sequence of items, such as a list or a tuple or a string. Then we also have the while loops, which continue to execute as long as a specified condition remains true. And as you might have guessed from the name, these loops are fundamental for tasks involving iteration, such as processing items in a collection, automating repetitive tasks, and handling dynamic data. Also, Python provides control statements like break, continue, and else within loops to manage their execution flow more precisely. So I'll start talking first about the for loops, and then move on to while loops. Okay, so in Python, a for loop is used to iterate over a sequence of items such as a Python tuple, list, string, or a range, which we'll talk about today. The loop's job is to execute a block of statements for each item in the sequence. So let's get a couple of terms out of the way first. A sequence of items that you can iterate through is called an iterable, or an iterable object. And as we iterate through the items one by one, we create a temporary variable called the iteration variable. Now this variable will change value each time it iterates in the loop. And one key component of a for loop is that the number of items in the loop is predetermined. So this means that you know when the loop will start and when it will end. So we will loop for a known amount of times. And the flow of the for loop is shown in this picture here. We loop for each item in our sequence, and the first question to ask is, have we reached the last item in our sequence yet? If no, then we enter our loop and run any statements we have in our indented code. Then we run the indented code, then we loop to the top again, and then we ask ourselves one more time, have we reached our last item in the sequence yet? Meaning, have we finished looping through all the items? And if the answer is no, then we loop to the top, take the next item in our sequence of items, set it as the iteration variable, then run the indented code once again. However, if we have reached the last item in our sequence of items, then our iteration effort is done and we exit our loop. So this is the structure of a for loop. We start with the for word, which is a reserved word, followed by the iteration variable, followed by the word in, which is another reserved word, followed by the name of the iterable object, then followed by a colon. And then under that is our indented code, which will run as long as we still have items in the sequence to loop through. So this structure is somewhat similar to an if statement, where we have the header line to check an expression, and if it's true, then we enter the indented code. But if it's not true, then we don't run the loop and go to the next line of code that is after the loop. Now in Python, for loops are also flexible, that we can exit the loop before we iterate through the entire list of items. For example, say you are iterating through 100 items, but if you reach an item with a specific attribute or a specific value, you may want to stop the loop for some reason. So in Python, a break statement is used within loops to terminate the loop prematurely when a specific condition is met. When the break statement is executed, the loop stops its iteration, we exit the loop completely, and control is transferred to the statement immediately following the loop. This is particularly useful for stopping a loop when a desired result is achieved or an error condition occurs, allowing for more efficient and controlled looping. Also in Python loops, we can have a continue statement. Now the continue statement is used within loops to skip the current iteration and proceed directly to the next iteration of the loop. So when a continue statement is encountered, the loop's remaining code for the current iteration is not executed, and control is transferred back to the beginning of the loop for the next iteration. This is particularly useful when we want to bypass certain parts of the loop under specific conditions without exiting the loop entirely, which helps to allow for more precise control of loop execution flow. Alright, let's switch gear now and talk about while loops. Now in Python, a while loop repeatedly executes a block of code as long as a condition is true. So the condition is checked before each iteration of the loop, and if the condition evaluates to true, the code block inside the loop runs. Now once the condition evaluates to false, the loop stops executing and the program continues with the next statement following the loop. So we can say then that while loops are useful when the number of iterations is not known beforehand, and the loop needs to continue until a specific condition changes. And within a while loop, the condition can involve any type of logical expression, including comparisons, function calls, and variable states. Now this flexibility allows for a wide range of applications, from simple tasks like counting, to more complex processes like reading data until a certain input is received. But please be careful. Special care must be taken to ensure the condition will eventually become false. Otherwise, the loop can become an infinite loop, running endlessly and potentially causing the program to hang or crash. So to avoid this, it's common practice to include statements within the loop that modify variables involved in the condition, and this ensures that the loop progresses toward termination. And I will show you an example of an infinite loop and how to evade it. This image outlines the basic structure of a while loop in Python, which emphasizes key components and their roles. So the while keyword is used to initiate a while loop. It signals to the Python interpreter that the following condition should be evaluated repeatedly to determine whether the subsequent block of code, which is the body of the loop, should execute or not. Then, right after the while keyword, we have the condition. This can be an expression which evaluates to either true or false. And this condition is checked before each iteration of the loop. And if the condition is false, the loop terminates and the program proceeds to the next statement following the loop. Then we have the colon at the end of the while line. This is a syntactical element that indicates the start of the indented block of code, which constitutes the loop body. The colon is a fundamental part of Python's syntax for defining the beginning of blocks of code that belong to control structures like loops, functions, and if statements. Now after the colon, the diagram shows that the loop body consists of one or more statements that must be indented to denote that they are part of the loop. This indentation is crucial in Python because it indicates the scope of the loop. Now the loop body will continue to execute as long as the condition remains true, and each time the loop body runs, the condition is re-evaluated before the next iteration begins. Now I can't emphasize enough the importance of indentation because it is a fundamental aspect of Python syntax. Proper indentation signifies which statements are part of the loop body, and without correct indentation, Python will not recognize the statements as part of the loop, which could lead to syntax errors or logical errors in the code. This diagram illustrates the flow of a while loop in Python when using the break statement. So here's the process step by step. The process begins at the start oval point, which leads to the evaluation of the loop condition. This is step 1, where the condition of the while loop is evaluated. Now this condition determines whether the loop body will execute or not. If the condition is false, the loop is exited and the flow moves to step 5, then step 6. But if the condition in step 1 evaluates true, then the body of the loop is executed in step number 2. The body contains the statements that should run with each iteration of the loop. Now, within the loop body, if a break statement is encountered, as seen in step number 3, Python immediately terminates the loop, bypassing the condition check for further iterations. This sends the control flow directly to the loop exit point, which is step number 6. But if a no break statement is encountered, after executing the loop body, the condition is reevaluated to determine if another iteration should occur, which is step 4, that loops back to step 1. So this diagram highlights the critical role of the break statement in altering the normal flow of a while loop. Now the break statement provides a way to exit the loop prematurely, regardless of the initial loop condition, which can be useful for scenarios like finding a specific item in a list, handling exceptions, corresponding to user input dynamically. Okay, so this diagram illustrates the flow of a while loop in Python when using the continue statement. We begin at the very top with the start oval, which then leads to the evaluation of the loop condition. So this is step 1, where the condition of the while loop is evaluated. Now this condition determines whether the loop body should execute. If the condition is false, the loop exits and the flow moves to step 6. But if the condition evaluates to true, then the loop checks for the continue statement as seen in step number 2. And if a continue statement is encountered, the loop skips the remaining statements in the loop body and goes directly to the next iteration, which reevaluates the loop condition as seen in step number 4. But if no continue statement is encountered in step 2, then the loop executes the body of the loop as seen in step number 3. This includes all the statements that are intended to run during each iteration of the loop. So to sum this up, the continue statement in a while loop is used to skip the current iteration and move directly to the next iteration by re-evaluating the loop condition. And this can be useful for situations where certain conditions within the loop should cause an early jump to the next iteration, effectively bypassing the rest of the loop body for the current iteration. So let's sum up the difference between the two loop types. This table compares for loops and while loops, highlighting their primary differences and typical use cases. So purpose-wise, a for loop is used to iterate over a sequence of items, such as list, tuple, or any iterable object. It is designed specifically for iterating over a predetermined sequence. As for design purposes, for loops are intended for situations where the number of iteration is known beforehand. They require a sequence to iterate over, making them ideal for fixed-length operations. And as for efficiency, when iterating over sequences, for loops are often more efficient than while loops because the number of iterations is predefined. This allows the loop to be optimized for performance. And now let me switch to while loops. Purpose-wise, a while loop is used to repeatedly execute a block of statements as long as a specified condition remains true. Now this type of loop is more flexible in terms of its control flow. As for design, while loops are used when the number of iterations is not known in advance, or when a block of code needs to run until a certain condition is met. So while loops require an initial condition that is tested at the beginning of each iteration. As for complexity and efficiency, while loops are more suitable for complex control flow situations where conditions might change in unpredictable ways. They can be more efficient in cases where the condition being tested can be evaluated quickly, even if the exact number of iterations is not known from the start. So overall, the table shows that for loops are typically preferred for straightforward iterations over known sequences, and while loops offer more flexibility for dynamic and condition-based iterations. Now the choice between the two depends on the specific needs of the task at hand, such as the predictability of iteration counts and the nature of the condition that is driving the loop. This slide demonstrates a while loop in Python for user validation, specifically for password entry. So the loop starts off with the condition while true, and since true is always true, then this while loop will always run, at least once, until something inside of the loop breaks it. So the loop runs indefinitely with while true, prompting the user to enter their password. Then the entered password is validated by the isValidPassword function, which takes one argument, the user's entered password. Now this function should have some requirements check to validate that the password meets all of them, like how many characters and what type of characters. Now if the password is valid, then the loop exits with a break statement. But if the password is invalid, then the loop prints out the message, invalid password, try again, and then continues to prompt the user once again. So this process repeats until a valid password is entered, ensuring continuous validation and user feedback. So again, the while true condition is a way to run the loop at least once, but please make sure to include some logic in the body of the loop to break out of the loop, otherwise you will have an infinite loop. This slide presents an example of a while loop used in the context of event handling within a game application. So the loop runs as long as the condition game is running is true, and within this loop, three functions are called sequentially: handle events, update game state, and render game. So first, the handle events function is responsible for managing user inputs and other events, ensuring that the game responds appropriately to user actions such as key presses or mouse movements. Secondly, the update game state function updates the game's logic, which includes modifying the game's data and state based on the events handled in the previous step. This could involve updating the position of game characters, checking for collisions, or advancing to the next level. And finally, the render game function is called to draw the updated game state to the screen, providing visual feedback to the player. So this loop continues to execute these steps in sequence until the condition game is running becomes false, typically when the player exits the game or a game over condition is met. This structure ensures that the game remains interactive and responsive to user inputs while continuously updating and displaying the game state. This slide illustrates the concept of dynamic data processing using a while loop to read and process data until the end of the file is reached. The loop operates under the condition while not end of file, meaning it continues to run as long as the end of the file has not been encountered yet. Now within the loop, we have the read next line function, and this is called to read the next line of data from the file. This data is then processed using the process data function, which handles the necessary operations on the data, such as parsing, analyzing, or transforming it. And following the data processing step, the loop includes a conditional check if condition met. Now this condition evaluates whether a specific criteria related to the data has been satisfied. If the condition is met, the variable end of file is set to true, which causes the loop to terminate. This setup allows for flexible and dynamic processing of data, where the loop continues to handle data lines sequentially until the defined condition signals the end of processing. And this approach is particularly useful for scenarios such as reading log files, processing streams of data, or handling large data sets that need to be processed incrementally. This slide shows a for loop, and in the provided code snippet, we see a list named numbers, which contains the integers 1 through 5. The intention is to calculate the sum of these numbers using a for loop. The for loop is a control flow statement that enables the code to iterate over each item in the list. So during each iteration, the current number is intended to be added to a running total called sum result, which in this case would be 15. Now, there's a built-in function in Python called sum, which you can just pass it a list as an argument to get the total sum, but I just wanted to show you a simple for loop as an example to iterate through a list of numbers and then add them together to give you the total. Alright, in the code provided here, we see a for loop, which again, as we know by now, is a control structure that allows a block of code to be repeated a certain number of times. Now this loop here uses the range function to create a sequence of numbers from 1 to 10. And for each number in the sequence, the loop's body, which contains the print I statement, is executed. The print I statement outputs the current number to the console to demonstrate how the loop iterates through the entire range. Now this example is a straightforward demonstration of fixed iteration, where the count is predetermined by the range specified. Again, it's a fundamental concept in programming that enables developers to perform repetitive tasks more efficiently. So the concept of fixed iteration is essential in many programming scenarios. For example, as in processing items in a list, or generating a series of numbers, or simply repeating an action a specific number of times. Understanding this concept is crucial for anyone learning to code, as it forms the basis for more complex operations and algorithms that one might encounter in the field of software development. In Python, there's the random module, which is a powerful library that provides tools to generate random numbers, select random items from sequences, shuffle data, and perform various other operations involving randomness. It is widely used in various applications, including simulations, games, testing, as well as security. And you can see from this slide that the random module comes with a slew of methods. I will talk about a few of them, like the random method, the randint method, and the randrange method. But please do look up the other methods yourself and learn more about them. Okay, so let's delve into an exciting feature of Python that opens up a world of possibilities, the random method, from the random module. Now this nifty method is quite straightforward. It doesn't require any arguments, and it just generates a random floating number between 0 and 1. Now you might wonder, why is that even useful? Well, imagine you're creating a game and you need to simulate dice rolls, or you're conducting a simulation where outcomes need to be unpredictable. So the random method is perfect for these scenarios, and it's incredibly simple to use as well. All you need to do is import the random module in your code, then just call random.random, and voila, you have a random number at your disposal. So as you can see, with just a couple lines of code, we can introduce randomness into our programs, making Python a powerful tool for developers and researchers alike. Now, if you don't want to generate a floating number between 0 and 1, but instead you want to generate actual numbers like integers, then the randint method is the way to go. It takes two arguments, start and stop, so you can control what numbers are returned. And the stop argument is actually included in the number generation. So in the code example provided here, we start at 3 and stop at 9. This means that the randint method can return a random number as either 3, 4, 5, 6, 7, 8, and also 9. So the randint method is a versatile and easy to use tool that can be employed in a variety of programming tasks which require random integer generation. Its straightforward functionality and the inclusive nature of the range make it a go-to choice for developers needing to introduce an element of randomness into their Python applications. Now, if you want a bit more control on your number generations, you can use the randrange method. This works pretty much like the randint method, but in addition, there is a third argument called step. So you still provide the start and stop arguments, but with the step argument, you're adding incrementation. So if I use the same start and stop as before, like 3 and 9, but then I add a third argument with a value of 3, then I will start at 3, then step or increment to 6, then step to 9. So this gives me more control on what numbers to include and exclude in my random number generation process. And you can also see in the middle of our screen that both the start and step arguments are optional, while the stop argument is the only required argument. For example, if I just have the randrange method with one argument, let's say 6, then Python will default to a start value of 0 and a step value of 1. Again, these are the default values if these values are not specifically provided as arguments. Alright, so I've been talking a lot, and now it's time for some code examples. So this code file is basically all about the random library and the different methods that come with it. Now, of course, there are more than just these 4 methods, but I just wanted to give you a sample of what type of methods and how they run. So I'm going to comment out just the last 3 lines and go line by line. The random method basically just returns a floating number from 0 to 1. So if I run this code once, I get a random number generated. Again, between 0 and 1, and it's a floating number. If I run it again, I get another randomly generated floating number between 0 and 1. So that's all what this random method does. It just generates a number, a floating number, between 0 and 1. So let's comment this out again. Let's bring this guy in. So the randint is a little bit different than random. And randint basically is going to return a random number between 3 and 10, including 3 and 10. Well, let's run it a few times and see if that's the case. So if I run this, I get 3. So now we know that 3, which is the start argument, is included. Let's run this again. I get 7. So 7 is between 3 and 10, so it's included. Let's run it again. I get 4. Let's run it again. I get 8. Let's run it again. I get 4 again. Again, it's a random generation of numbers. Okay. And there you go. Now 10 is also generated. So this basically tells us that the start number and the stop number, both of them are included. Okay, and this is just proof that every time we generate a number, we get a different number, but not any random number. It's a number that's from 3 to 10, including 3 and 10. So that's what randint does. Let's comment this guy out. Let's bring this in. So the rand range basically works kind of the same way as randint, but we have a third argument that's added. So the first argument is the start, the second argument is the stop, and the third argument is the step. So the rand range method is going to randomly generate a number that can be any number from 0 to 10, including 0 and 10, but it has to be increments of 3. So if I start at 0, I'm not going to get 1 or 2 back. I could get 3. I'm not going to get 4 or 5 back. I might get 6. I'm not going to get 7, 8 back. I might get 9. Okay, why is that? Well, because I'm specifically said that I want to use not every number from 0 to 10, but only increments of 3. All right, so let's test this out. I got 0, okay, because that's the start. Let's run it again. I got 6, so 6 is a correct random number because it comes in steps of 3. So again, 0, 3, and 6, and 9 would be possible random numbers. So let's keep running it again. 6 again. It's okay to get duplicate numbers, it's random numbers. 3, I'm trying to see if I can get a 9. Okay, 0 is also possible because it's starting point. There we go. So here is 9. So again, starting at 0, including 0, ending at 10, including 10, but increment at 3. So that's why we're never going to get 10. We're only going to get increments of 3 starting at 0. Let's comment this guy out. Let's bring this one in. All right, now the sample method basically takes a sequence of items, which could be a list, and it's basically going to sample a certain number of items, and that certain number is in the second argument. So the sample method takes the first argument, which includes the sequence or the list of items, and then the second argument is going to say, well, how many sample items do you want to return? Okay, so now I have a list of 1, 2, 3, 4, 5, 6, 7, and I want a sample of 2. So this is going to randomly choose 2 items from this list. If I run this, I get a list of 3 and 6. So that's a sample of 2 from this list here. Let's run it again. I get another random sample, which is 7 and 4. And if I run it one more time, I get another random list, which is 6 and 2. So this is what the sample method does. And again, these are just 4 methods which are part of the random library. And again, there are many, many more. So please explore them by going through the Python documentation. Now I wanted to talk about the range function, which is a built-in function in Python, mainly because it's used a lot with for loops. So I'm not going to show you any for loops in this code example. I'm just going to talk about the range function itself. Okay, so if I comment this out, this basically says print for me the range 0, 10, and 1. And as the text up here, it says the range function returns a sequence of numbers starting from 0 by default and increments by 1 by default, and then stops before a specified number. And the syntax for it is use the range, the name of the function, followed by the start argument, then the stop argument, then the step argument. Okay. Now, a lot of people say, okay, I can basically say range and then say 0, 10, and 1, and that's going to return for me the actual numbers. Well, let's test this out using a print statement and see what happens. So I just have a print statement. I'm going to pass it the range of 0, 10, and 1. So technically then I should get the numbers of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't include 10 because again it says stops before a specified number. So 10 is not going to be included. So I'm going to guess that the range method is going to return all these numbers for me. So let's run this and see what happens. Alright, all I get back is range 0 to 10, which is not what I expected. But that's the correct output. So if you want to see what sequence of numbers get returned from the range function, there is a way to unpack all the sequence of numbers. And the way to do that is using the star sign right before the function name. So let's comment this out and let's bring this in. Alright, so I have a print statement and the print statement is going to pass this text followed by a star and then range 0, 10. Okay, so I know that 0, 10, the sequence of numbers included in 0, 10 are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but I want to print it out just so I can get a confirmation for it. And the way to do that is not just say range 0, 10, but to do a star or an asterisk range 0, 10. So if I run this now, Python unpacks all the numbers that are part of the range 0, 10 function call. Okay. All right, so now that we know that the first argument is going to be the start and then last argument is going to be the stop, then the output is going to be 0 all the way through 9. Okay, and just to confirm also, let's do another example. This time I'm going to do a range 1, 10. So technically I should get starting from 1 and not include 10, but stopping right before 10. So it should be 1 through 9, just like I have here. This is the comment part. So if I run this, F5, range 1, 10 is going to unpack or includes numbers 1 through 9. Doesn't include 10 because we stop before the stop sign. All right. Now let's bring in another code example. This time I'm going to pass not just 2 arguments, but I'm going to pass a third argument, and the third argument is the step. So I'm going to start at 1, I'm going to stop at 10, meaning not include 10, but only stepping through by 2s. So if I start at 1 and step by 2, then next number is going to be 3. And then from 3, step by 2, I'm going to get 5. And then step by 2, I'm going to get 7. And then step by 2, I'm going to get 9. And that's where I stop because the ending is 10. So I should get back 1, 3, 5, 7, 9. All right, so basically what I'm trying to get is I just want to show you what this function holds as sequence of numbers, just so you can understand. All right, so if I run this code, F5, I get as expected. Range function that has starting point 1, stopping at 10, increment at 2, it will actually include these numbers here. All right, now we can also do backward flow. So if I get rid of, all right, so if I say range 25 to -2, well, we're going to start at 25 because that's what this argument is. We're going to stop at 2, and then for my step I have a -2. So negative means you go backwards. So that means I'm going to start at 25. You can see here I'm going to start at 25, that's my starting point, and then increment by or step by -2, so make it 23, and then backwards another 2, be 21, 19, 17, and so on and so on. So that's what the negative in a step argument mean. And if we test it out, that's exactly what I get. All right, I go all the way to, I stop at 3 because my stopping point is at 2. So if I would continue from 2 using -2, I would go down to 0, or technically, sorry, go down to 1. That's the next increment by 2. But 1 is not part of 25 to 2 range. Okay, now the range function only takes integers. Okay, so if I bring this guy in and I try to do a range of 5.5, which is a float, this will generate an error. So let's see that in action. There we go. So I get a type error, and the message is float object cannot be interpreted as an integer. Okay, so the range function is expecting integers for arguments. All right, let's comment this guy out again, and let's bring this one in. Now this says print the unpacked sequence where we start at 1, stop at 10, and increment by -1. Now the reason I wanted to show you this example is because I want to show you the error. So let's comment that back in. Let's run this, and nothing happens. So I didn't get an error, but I did not get any value back. Now the reason is because if we look at this and try to understand it based on what we've learned and based on the arguments, so this says basically this is going to hold a sequence of numbers that starts at 1 and then stops at 10. But we're going to be going in the -1 direction. So -1 meaning that we're going to go backwards, incrementing by 1. So if I go from 1 to 10 negatively, meaning in the opposite direction, so that means I'm going to go 1 and then 0, -1, -2, -3, and so on. But my numbers that start and stop are from 1 to 10. So there are no numbers to unpack or are part of the sequence using these arguments. And the reason why I had a testing after here just is to show you that the code is still running. Okay, so this print statement is going to generate nothing, and then the print statement here is just going to generate the string testing after. So if I run this again, F5, okay, nothing was generated on this line, but then I get the testing after. So again, I just wanted to show you what this range function does, because you will be seeing it a lot or working with it a lot when we do for loops. In this code example, I'm basically going to show you a while loop and a for loop. And you're going to see that the output is exactly the same thing for both loops. So you can do the same thing using two different loops. One is going to be more efficient than the other, and we're going to find this out now. So beginning with the while loop, I start by defining a variable called product set equal to 1, and then I have another variable called number set equal to 1. And then I have my while header, or my while rule, and what I'm saying here is while number is less than 11. Now as long as this rule answers to true, then I'm going to run this indented code. Okay, now number so far has been defined as 1. So while 1 is less than 11, yes, that's true, then run this code. Now what this is going to do is it's going to take product, which right now is defined as 1. It's going to take product, which is 1, multiplied by number, which is also 1. This is on the first iteration. Okay, so 1 times 1 is going to be 1, which is going to be assigned to the value product. Then I'm going to print whatever that value is, which is 1. Next, I'm going to increment my number value, which so far is just 1. I'm going to increment it by 1. This is the shorthand to increment, or you could also do it this way. Number equals to number plus 1. So this is how we can increment a variable by 1. This is the longhand version, and this is the shorthand version. And when I increment the number by 1, again, number on the first iteration was 1. Now I'm going to increment it by 1, so now number is going to become 2. And then we go back to the top of the loop again. While 2 is less than 11, that's true, so I'm going to run this code. And then I'm going to increment number by 1. So it used to be 2, now it's going to be 3. Then we loop again to the top. While 3 is less than 11, that's true, so I'm going to enter this. So this is going to keep running and running and running, and every time it runs, it's going to increment the number variable by 1. So we go to 3, and then run again, then 4, run again, 5, run again, 6, run again, and keep going and going and going until number if number is 10, 10 is less than 11, that's true, then add 1 to it, becomes 11. While 11 is less than 11, no, that's not true. So that means the while loop will stop to run, because the rule here, while number is less than 11, is not true anymore, because 11 is not less than 11. 11 is equal to 11. So the while loop is going to stop running, and we exit the indented code, and then move on to the next line of code in our code file. So actually, before I talk about the for loop, let's run the while loop. So let me comment this out and see what happens. F5, and there we go. So we get, on the first run, I get a 1, and then a 2, and a 6, 24, and so on, so on, so on. But it only ran 11 times. Okay, actually it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. Okay, because we didn't make it to 11 times yet. All right, but the reason why this while loop ran and then stopped is because there was the number value, or the number variable, kept changing and incrementing to a point where this statement eventually will become false. All right, now if I comment this line out, okay, then while number is less than 11, what is number? Well, number is 1. Okay, so while 1 is less than 11, that's true. Then I'm gonna run this code and then go back to the top again. While number is less than 11, well, what's number? Well, number is still 1. Number value has not changed, it's still 1. So while 1 is less than 11, that's true, then run this code. then go up again. While 1 is less than 11, that's true, then run again. While 1 is less than 11, still true, then run again. So this is what's going to lead us to an infinite loop. And the reason why is because the while loop will continue running as long as this condition is true, but nothing is changing in my code to change this to false at all. So if I run this code now, as is, look what's going to happen. If you can see the spinning beach ball, that means my computer is overworking, and it's just, I don't see my output for some reason, but you can guess that the machine is overloaded and it's just going into an infinite loop. So I have to terminate this program. And you can see here that my program is not responding, so I'm going to force quit. So again, anytime you want to use a while loop, just make sure that you have some logic in your code that will eventually make this statement a false statement, so you don't enter into an infinite loop. All right, let's comment this out. Let's bring in a for loop. Okay, so this for loop does exactly the same thing as the while loop, but in a for loop scenario. So I'm going to start with a variable called product equal to 1. Then I'm going to have a list of numbers or a sequence of numbers in a variable called numbers. And the sequence of numbers are going to be based on the sequence of numbers that I get back from this range function. And we learned about the range function a few minutes ago. So this range 1, 11 basically is going to return a sequence of numbers that starts at 1 and stops at 10, not 11, doesn't include 11, and it's going to be incrementing by 1. So this is going to be basically, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, that's what range 1, 11 unpacks to these numbers. Then we come to the for loop. So the for loop is going to use the for keyword followed by an iteration variable. So this variable, you can call anything you want. In this case, it's called number. This variable is going to be on the first iteration, it's going to be the value 1. On the second iteration, it's going to be a value 2. Third iteration, 3, and so on. And it's going to keep looping one by one every time it takes a different value. And once it's done, there are no more items in the sequence, then we exit the loop. So the for loop, as opposed to the while loop, kind of has a built-in anti-infinite loop mechanism, because it's only going to run a certain number of iterations based on the certain number of items. So this makes it more efficient, and I also don't have to include logic in my for loop that basically says, change number to a value that eventually is going to make this statement false, like we did here in the while statement by using an increment of a variable. I don't have to do this in my for statement. And if I run this code, F5, I get exactly the same output that I did with a while. So again, the difference between for and while, for we know how many times this is going to run for, while is going to continue running until this rule becomes false, which can lead us to infinite loops if we don't write the logic correctly. Okay, so here is the week 5 module, and as you can see, it contains 3 items under the assignment section. And I wanted to revisit the concept of the attendance check. Mainly, I wanted to mention that sometimes you email me last minute on Sunday evening and tell me that you can't submit the assignment for some reason. So this is fine, but for you to count as present for that week, you must submit something. So in those cases, please let me know by email that you need a time extension for the assignment, but you also must complete the attendance check assignment, which will then trigger your present status for that week. The point is that you must submit something each week. So again, if no assignment is being submitted, then please submit the attendance check. And if you have any questions on that, please reach out to me at any time. Now the next assignment on the list is the first challenge assignment, and I'll come back to that in just a moment. And the last item in the assignment section is an extra credit mid-semester survey. You can see that it has a 0 points value, but if you do complete it, then you will be awarded 5 extra credit points. So please take a few minutes to complete it, and please be as honest as possible in your responses. These surveys are anonymous, so while I do not see who wrote what, I do see the results in general. And it's to my own benefit, as well as yours and future students, that you share your honest and true opinion. So please say what you like about this class so far and what you don't like and what can be changed. Even if you feel that I'm doing a horrible job as a teacher, please by all means do say so, because I need to know so I can improve on my teaching habits. And once you do complete the survey, you will receive an email. Please take a screenshot of this email and then submit the screenshot to earn the full 5 points. Alright, so let's go back to the Challenge 1 assignment. So last week in the Lab 1 assignment, we worked with variables, if statements, and functions in order to build a chatbot. And now this week we are going to build our own chatbot from scratch in VS Code using the same skills. You'll also need to create a write-up about your code in a Microsoft Word document. Now the requirements for the code are listed here, followed by the requirements for the Word document. And below that we have a list of ideas to help you come up with your code idea. Now you are free to create any code you like from scratch, but just make sure that you meet all the requirements. And of course, please test your code to make sure that it runs correctly, and please test different scenarios as well. And ultimately, what you need to submit is a .py file along with the Word document. So here's my code example, and this time around you can't use this code idea or the code itself. Sorry. But this code and this code idea does meet the requirements for this assignment. It has a function, it has if statements, it has variables, and it also has multiple user interactions, which you will see once the code runs. I also have some comments which are part of best programming practices. And for some extra pieces, which are not required for this assignment, I'm importing and using the random module. I'm also using a while loop. And I'm using the try except block. Now, this code is a guessing game. It prompts the user to guess a number between 1 and 20. The user has 5 attempts to guess it correctly. Otherwise, the game will be lost and then terminate. And with each incorrect guess attempt, the code will tell the user to either guess higher or lower, depending on the situation. So let's run this code and see how it works. So I'm prompted with a welcome message and then instructions that I have 5 attempts to guess a number between 1 and 20, and then I'm prompted with the enter your guess for the first attempt. So I'll start with 10, hit enter. Then it tells me try a lower number, and then for attempt 2, enter your guess. So something lower than 10, let's do 5. I'll hit enter. Now it says try a higher number, so let's do 8, hit enter. Try a higher number, so I guess it's going to be 9, and that should be the right answer. And there we go. Congratulations, you guessed the number 9 correctly in 4 attempts. Alright, let's run this game again, and let's see what happens when I fail to guess correctly. So I'm going to type 20, hit enter. It says try a lower number. I'm just going to type 20 again so I could fail. So I failed on attempt 1, attempt 2. Let's try the same number for attempt 3. Again, I'm testing a wrong scenarios to see exactly how it's going to end. And then hit enter, and then 20 again, hit enter, 20 again, hit enter. And then since I ran out of the 5 attempts, it gives me the message, sorry, you've reached the maximum 5 attempts. The correct number was 2. Okay, and let's try another run, see if I could break the code and see what happens. So enter a guess. I'm going to type, just gibberish, hit enter. As an invalid input, please enter a number 1 through 20. Okay, so I've tested now the try and accept block, and I could see that it works correctly. Alright, so again, with your own code, please make sure that you test it out thoroughly. Try to break it to see how it behaves, and we should not get any, traceback errors. Alright, so once you're happy with your code and that it runs correctly after different testing scenarios, then please create your write-up document and then submit both the .py file and the Word document. Alright, so that's it for the week 5 video. I hope it was helpful for you. If you have any questions, please don't hesitate to reach out to me at any time. Thank you for watching, take care, and bye for now.